So we're going to look at our additional test review that you guys did in class. So let's go over it. So we have our first equation is in slope-intercept form already, and we know our y-intercept there is at 3, and the slope is telling us to go up 1 over 2. That's what a half is. Up 1 over 2, up 1 over 2. So our first graph is going to look like that. All right, now let's write down what it is. It's y equals 1/2 x plus 3. That's our first equation. Now let's look at the second one. The second one here is in slope standard form. So we have to come up with our slope and our y-intercept. And we know it's a over b with a negative in front of it. So 4 over 2, 4 divided by 2 is 2 with a negative in front of it. So our slope is -2. Our slope is -2. And our y-intercept we know is going to be at 0. And 2 times what makes -4? 2 times -2 makes -4. So that's all we need to graph our second. So we start at -2. It's telling us to go down 2 and over 1. Down 2 over 1. So let's grab our second equation. Our second equation is right there, and we know that second equation is 4x plus 2y equals -4. So we have our point of intersection right there. And let's just check it. If we go up 2, back 1, up 2, back 1, yep, works there. Okay. So that point of intersection is -2, back to the left 2, and up 2. So it's -2, 2. Let's check and make sure it works. So in equation 1, our y is 2. Our slope is 1/2. Our x is -2. And we're adding 3. So this is the first equation. Half of -2 is -1. Let me write that down. 2. So half of -2 is -1 plus 3. And -1 plus 3 does equal 2. So it checks for our first equation. Let's check with the second equation now. 4 times our x is -2. Plus 2 times our y is 2. And that's supposed to equal -4. 4 times -2 is -8, plus 4 equals -4. -8 plus 4 does equal -4. We're good to go. So that's the end of our first problem. We've got it. Our common solution, our point of intersection, 0, -2. That's our final answer. And we're done with problem 1. All right, problem 2, they're both in standard form. So our first slope is 3, A is 3, B is -2, and we have to put a negative in front of that. So the slope for our first line is 2 negatives make a positive, so it's 3/2. And our y-intercept is at 0. -2 times -6 makes a positive 12. So there's our slope and our intercept for our first line. Our second line, our A and B are both 1, and we have a plus in between them. So let's see, A, B, and we have to put our negative in. So our slope is -1. And our y-intercept is at 0, 9. Okay, so we got everything we need. Our first slope and our first intercept, we start at -6. And that's telling us to go up 1, 2, 3 over 2, up 1, 2, 3 over 2, up 1, 2, 3 over 2. So there's our first line. And that line is 3x minus 2y equals 12. Right? Okay, let's get to our second line. We know that our intercept our y-intercept is at 9, and it's telling us to go down 1 over 1. That's what the slope's telling us to do. Down 1 over 1. Down 1 over 1. Okay, I think we've got enough points. Let's graph. Over 1, down 1, over 1, down 1, over 1. There we go. So let's put in our second equation. X plus y equals 9. And our point of intersection is right there. And that point is at 6, 3. 6, 3. So that's our point of intersection. Now we're asked to check it. So in our first equation, we have 3 times 6, that's our x, minus 2 times 3, that's our y, is supposed to equal 12. 3 times 6 is 18, minus 6. 18 minus 6 does equal 12. We're good for our first equation. Let's look at the second equation now. X is 6. Second equation is over here. Plus our y is 3, and that's supposed to equal 9. 6 plus 3 does equal 9. So we're good in both cases. So once again, our common solution for this system is 6, 3. And that's our final answer. 0.63 is our common solution. Okay, so we're going to go with number 3. I know I'm using a pen, and I don't like you guys using pens. I'd prefer you to use pencils, but I think it shows up better on the video. We're going to give it a try. But please, use a pencil, okay, when you're doing this stuff. Okay, so we have 6x minus 2y equals 30, and we want to find the y-intercept. So we know at the y-intercept, well, we're looking for y, so our x is 0, and we want to find our y. Negative 2 times what is 30? Negative 15. Remember what we're really doing there? We're dividing both sides by negative 2, and that's how we get the negative 15. Okay, x-intercept. X-intercept, we're looking for x, so we want y to be 0. So y is 0 there. 6x equals 30. 6 times 5 equals 30. Okay, slope. How do we find our slope in standard form? We take a, which is 6, over b, which is minus 2, and put a negative in front of it. 2 negatives make a positive. 6 divided by 2 is 3. There's our slope. We could also do it by using our change of y over change of x. Negative 15 minus 0 over 0 minus 5. That would give us a negative 15 over negative 5. 15 divided by 5 is 3. So either way, we get a slope of 3. Now, we're told to provide an equation in standard form whose graph is parallel to this line, So we want to have the same slope, because we know parallel lines have the same slope, different intercepts. So we could use 6x minus 2y and just change the constant on the back. Whatever, let's make it 50. Why not? Okay, and that would give us a y-intercept of negative 25. Obviously, that's different from negative 15. Same slope, different intercept, we're good to go. If you didn't want to use the same coefficients, as long as they become 3 when we divide them, it's fine. So could we use, let's see, could we use 10? Well, 10 is going to be a problem. We're going to get a fraction, so let's not use 10. That would be an ugly number. But let's see, what could we use? How about 15x and 15? Let's see, to get 3, we could make this 5y. And we want it to be positive, so we're going to put a negative in between, right? Because that's going to give us the negative here and that negative, our double negative like we had there, right? And then let's give it a number behind it. Whatever. Let's make it something that works out kind of well. So 15x minus 5y equals 60. Remember, guys, there's thousands and thousands and thousands of equations we could use that are parallel, as long as we keep same slope, different intercept. Okay, let's get to the final question in number 3, and that is E, and it says perpendicular. Our slope is 3. Perpendicular slope, we have to change. Perpendicular line, we know we have to change it to a negative reciprocal of that slope. So negative reciprocal, we got to flip it. And since this is positive, we want to make it negative. Okay? So there we go. We have a negative 1/3. Now, once again, we could write this, first of all, in slope-intercept form. That would give us negative 1/3 x and give it any kind of intercept we want on the back. We could use whatever. We could use 9 if we want, okay? And then you could transfer it into standard form. And we have another video where we go through that. Or, as we talked about in our previous video, all we have to do is change the coefficients. So we're going to put a 2 in the front here and a 6 in the back. And let's see, 2 over 6. Obviously, we've got to put our x and a y there. And let's see, so 2 over 6, if we make this positive, that's going to be negative. Oh, that, I believe, would work. 2 divided by 6 is 1/3. And remember, it's negative a over b, so that gives us our negative in front, so that works. The plus helps us make that negative as long as neither one of the coefficients are negative. And then we just got to give it a constant in the back. I'm going to make this 50. Doesn't really matter what it is, right? As long as we've got the negative reciprocals of that slope. So let's get to question number 4. Number 4 says calculate the solution of a system that includes those two equations. They're both in slope-intercept form, so we can set them equal to each other. We can use equality to find the common solution, or the point of intersection. Another way of saying that if we're talking about the graphs. So we set those two equations equal to each other. We have x's on either side, or both sides of the equal sign. We want them on one side. So I'm going to do it different than I did it on the last video. This time I'm going to move the x's to this side. So I have a negative 4x, so I have to add 4x to this side, which means I have to add 4x to that side. So let's see, negative 4x plus positive 4x, that gives us 0, so we're left with 5 over there, equals 2 x's and 4 x's gives us 6 x's minus 7. Okay, we got constants on both sides. Now let's get them on the same side. So 5 equals 6x. I'm just rewriting it up here. And we're taking away 7. We want to get that 7 over with the 12. So let's add 7 to both sides. Put our equal sign where it belongs. We have 12 equals 6x. And just like we did on our, when we're looking at the slope intercept and all that stuff, we could say to ourselves, well, 6 times what equals 12? 6 times 2 equals 12. Or we could do the math, divide both sides by 6, and we end up getting x equals 12 divided by 6 is 2. So we're right. Now, that's only our y. We still have to find the other part. So we know this is just the x part, that's 2, and we still have to find the y. So we're going to put it back into the equation, negative 4 times 2 plus 5, and that's going to equal 2 times 2 minus 7. Ooh, I'm going off the page here a little bit. Let me move this over a little bit so you can see it. Okay, there we go. Okay, how did I get this? Remember, I put the negative 2, or I put the 2 into the first equation and the 2 into the second equation. And we just got that from where we were before. Okay, so we got negative 8 plus 5 on this side equals 2 times 2 is 4 minus 7 on this side. Negative 8 plus 5 is a negative 3. 4 minus 7 is also a negative 3. So there's our y, negative 3. So our point of intersection is 2, negative 3. That's the point where these graphs would intersect. That's also called the solution of this system. Provide an equation in slope-intercept form whose graph is parallel to the graph of 3x minus 9y equals 18. Now this is in standard form, so we know once again the slope is a over b with a negative in front. So we have a negative in front. A is 3. B, in this case, is 9 with a negative, so that's another negative. So that gives us 2 negatives make a positive, and we have a slope of 1/3. The y-intercept we know is x is 0. Negative 9 times what is 18? Negative 2. So we have our slope, we have our y-intercept. Parallel, we know we want to have a same slope but a different intercept. So all we have to do, and we want to write this in slope-intercept form this time, is write 1/3 x, and then just give it a different intercept. The intercept there is -2, so we can give it whatever we want. We could even make it +2 if we want. Same slope, different intercept, and in slope-intercept form, so we're done with number 5. Number 6, we're told to rewrite 4x minus 2y equals 20 in slope-intercept form. Once again, we need the slope and the intercept, and we know our slope is a is 4, our b is -2. We have another negative in front of it, so our slope is here is going to be 2. Our y-intercept, y is 0. -2 times what is 20? -10. Okay, and they just wanted you to write it in slope-intercept form. So we have our slope, we have our intercept, so y equals 2x minus 10. And that's our answer. All we were asked to do this time is to rewrite this in slope-intercept form. So we can find our slope, we can find our intercept, and there we go. We're done with that problem. All right, this time we were given an equation, write an equation in standard form whose graph is perpendicular to the graph of y equals 10x plus 17. Perpendicular, y equals 10x plus 17. Well, we know that perpendicular to the slope has to be a negative reciprocal. So the negative reciprocal of that slope, slope is 10, so we'd have 1/10 with a negative in front of it. 1/10 with a negative in front of it. And it doesn't matter what we put in for the intercept, so we could pretty much write this right now, but it needs to be in standard form. Well, let's start by writing it in slope-intercept form. Do it a little bit different this time. So 1/10x, and then we'll just give it an intercept. Let's do 5. Why not? Okay. Now, right now that's in slope-intercept form. We want to rewrite it in standard form. Okay. So the best way to do that, let's get rid of our denominator. Okay. Let's get rid of the fraction. So if we multiply everything in here by 10, every term on both sides, we get 10y equals the 10, this 10 and that 10, 10 divided by 10 gives us 1. So that's why we're doing it. We're trying to get rid of that denominator. So on the top, we're left with just -x, or -1x if you want to write that. And we got to distribute that 10 to the 5 too, so we get plus 50. Okay, so now we can see our fraction is done, but our work is not. We still don't have this in standard form yet. Standard form, remember, x and y are on the same side. So if we want to get x to the other side, we can add x to both sides. So I'm going to add x on this side. And if I add x on this side, -x plus x, the x's are gone, right? So in essence, I move the x to the other side, no more x here, and I just have the 50 left. Now remember, in standard form, the leading coefficient, the coefficient in front of that first term has to be positive. It is positive. It's a positive 1. So we're good, okay? We don't have to rewrite anything here. So our answer is x plus 10y equals 50. We're done with the problem, okay? If this was a negative, we'd have to change some signs, but it's not, so we're finished. The last question on here asks us to define x-intercept. And I know my handwriting is bad. This is why I've been using the PowerPoint, but for this one, we're going to do it by hand. So the point or points of a graph that intersects the x-axis. Remember, that's what an x-intercept does. It intersects, not intercepts, intersects the x-axis. And what's always true there? At this point, the y-coordinate is always 0. So y is always 0. So our y is here, and we're looking for x. So remember, x-intercept, we're looking for x, the y is 0. All right? And that's the end of this review.